Right now, there's a Hantavirus outbreak on board the cruise ship called the Hondius. There's 6 confirmed cases and at least 3 fatalities, and a virus that kills more than a third of the people it infects. So today I want to explain what actually happens inside the body, because the biology behind why this virus is so dangerous is far more interesting than anything else you'll hear on the news about this. But first, can it spread between people? Almost all hantavirus strains cannot. You typically get infected by inhaling aerosolized particles from infected rodent feces, urine, or saliva. The Andesvirus, confirmed in this outbreak, is the one known exception with documented person-to-person transmissions. But even then, it requires prolonged close contact. So let's get into what actually happens when this virus infects you. When you inhale aerosolized particles containing the hantavirus, the virus crosses the respiratory epithelium in a way that's not completely known. And then it reaches the capillaries that are underneath. These are the smallest blood vessels in the body. They are lined by a single layer of endothelial cells. And it's these endothelial cells that are the central target of the hantavirus and also thus the central theme throughout this video. Once it's inside these cells, the virus starts replicating. And this is what makes the hantavirus unusual. It doesn't destroy the cells that it infects. The endothelial cells remain largely intact. Instead, the virus sort of activates them. And it's that activation which increases the permeability of the capillary wall. And as a result, the fluid starts leaking out of the bloodstream into the surrounding tissue. And depending on where that happens inside the body, the consequences can be quite different. During the early phase, before much fluid leaking, you feel nothing. The incubation period is typically 2 to 6 weeks, during which the virus quietly spreads throughout the bloodstream to the endothelial cells in other organs, in the kidneys, the spleen, the heart, and the lungs. And by the time symptoms appear, the infection is already well established. And this is where hantavirus strains diverge into 2 distinct clinical pictures, depending on which vascular cells are most severely affected. In the hantavirus strains from primarily Europe and Asia, the capillary leak is most pronounced in the kidneys. The endothelial activation disrupts the filtration in the glomeruli, causing what's called a hemorrhagic fever with renal syndrome, or HFRS. Patients develop acute kidney injury, low platelet counts, and in some cases bleeding. And these strains are serious, but have a relatively lower fatality rate of roughly 1 to 15%, depending on the specific strain. In the Andesvirus currently circulating on the Hondius, the capillary leak hits hardest in the lungs. Fluid pours into the alveolar space, which are the tiny air sacs where the gas exchange happens, and the patients develop what is essentially a drowning from the inside. This is hantavirus pulmonary syndrome, or HPS. It progresses rapidly and has a case fatality rate of roughly 35 to 40%, which is what makes this Andesvirus particularly dangerous. In both syndromes, the hemorrhagic component, which is the bleeding tendency that comes from the same source, the endothelial activation triggers several contributing mechanisms, including the release of VEGF, which causes further increase in vascular permeability. Also the activation of the systems producing the bradykinin and the general pro-inflammatory state, so together these drive the capillary leak. The other gruesome detail this virus causes is coagulopathy. Viral components on the inside of the endothelium can attract platelets, which can ultimately cause a reduction in the total platelets in the blood. This is called thrombocytopenia. This lack of platelets in the blood means that your blood also won't coagulate or clot as it should when you have a wound, thus causing even more bleeding. So why do some patients die? In the case of the pulmonary syndrome, the pulmonary edema progresses very rapidly, sometimes within hours of symptom onset. And as the alveolar space fills with fluid, the oxygen exchange becomes incredibly difficult, and the patients develop what's called an acute respiratory distress syndrome, or ARDS. The heart is now working against severely compromised lungs and can go into a cardiogenic shock. It is a cascade that can be extremely difficult to interrupt once it begins, which is why the fatality rate is so high, even with intensive care. There's no specific antiviral treatment for the hantavirus. Management is entirely supportive. So you have mechanical ventilation, oxygen, managing the fluid balance very carefully, although the challenge is that at the same time, the capillary leak that is flooding the lungs means that giving too much fluid intravenously can just make things worse. It is a very difficult balance to strike. So, that's what hantavirus actually does inside the body. A virus that doesn't just destroy its target cells, but instead quietly activates them, causing the smallest blood vessels to leak, and in the case of the Andesvirus, flooding the lungs in the process. If you enjoyed this video, please let me know, and also let me know if there's anything about this hantavirus that I've missed. Also check my other videos, for example, this one on the 5 diseases that science has actually nearly solved.